All right, we're going to do lesson 5, and you should have this sheet out that I provided for you. There's a few ways you could do this. You could try to do the problem, and then when you get stuck, watch the video. You could do the problem, then watch, not the video, but pause it, watch me do example 1. Or watch me do example 1, then try it yourself, do it at the same time, or whatnot. But you can pause, go back, whatever. But you're going to be doing these and also taking a picture of the notes and sending them off to me as well. So here we go. We're going to do example 1, and what we're trying to say 2 times the cosine of what angle equals -1. That's this problem in English. So the way we do that is you always want to get your trig function isolated. So if we divide both sides by 2, you're going to have the cosine of what equals -1/2. Okay, now if you think about your unit circle, where is the cosine going to be -1/2? Well, I'll show you. Here's your unit circle, and it looks like right here is where your cosine is -1/2, and that is at 2 pi over 3. Okay, now the cosine is also -1/2 down here, okay, and that is actually 4 pi over 3. So those are the 2 places where they are, where the cosine is -1/2. Now there is something they talk about called 2k pi, and I want to talk to you about that. K means any number. So what you want to think about is, if I took it out, 2 pi is the distance is around the circle, the distance around the circle, right? Now whatever number you put in front of here, it's just how many times you're going to go around the circle. So they have this new idea here, is the answer to this isn't just here, but it's also if you go around the circle again and again. So you could find the cosine could be -1/2 many times, depending on how many times you go around the circle. So here's how they answer that. The cosine is -1/2 at 2 pi over 3 plus 2k pi. All right, so that's talking about this angle. And then it also, we're going to say and, it's also at 4 pi over 3 plus 2k pi. So there's your answer. And the book has this, so if I go too fast, you don't understand, go ahead and look in the book. They also give the answer in degrees. Most of the time we're going to stay in radians, so I'm just going to leave it in radians. The book also tells you that that's 120 plus k times 360 instead of k times 2 pi. So go ahead and peek at that. We do the same thing with this, is we're going to get the sine squared x all by itself. So that sine squared x equals 1/4. So what they're saying really is, if you take the sine of, is that how I'm going to say it? Okay, so how we get, algebraically, how do we get that alone is you would take the square root of both sides, right? So that leaves you with sine of what angle equals plus or minus the square root of 1/4, which is plus or minus 1/2, okay? So what we are basically saying is where, and this is also synonymous to saying, what is that? Okay, we're basically saying, what's the angle? What's the angle when the sine is positive or -1/2? So I'm going to peek back up here at this unit circle, and the sine is 1/2 right here, and right here, and right here, and right here. So at pi over 6, 5 pi over 6, 7 pi over 6, and also 11 pi over 6. So in 4 places, it is either positive or -1/2. So we're still going to do this 2k thing, 2k pi. So you're going to have lots of options here. If we're talking about this at pi over 6, you're going to say the answer is pi over 6 plus 2k pi. And then if we're talking about this angle right here, it's 5 pi over 6. 5 pi over 6 plus 2k pi. And we're going to do this one, which is 7 pi over 6 plus 2k pi and 11 pi over 6 plus 2k pi. So I hope you're not freaking out over this 2k pi thing. They're just saying if you, that's the spot, and then if you keep going around and around in a circle, and that's going to be the same, you're going to be landing in the same position every time when you add the 2k pi. So these are all the answers. So so it's a list, okay? These are all 4 infinite number of answers, actually. Okay, example 3. This is a little weird because we have a double angle. So first, let's isolate that. We solve for tangent of 2x, and that's going to be -1. Okay, and then this is kind of a big deal too. So we're trying to find the answers to this within this interval. Okay, but in order to do it with a double angle, we're looking for solutions to x, solutions for x between these numbers. Okay, but because we have a 2x, the interval to find, we're going to first do this. And the book shows you as well, and it might be confusing until you do some practice of your own, but just know this, okay? So we're going to find all the angles between 0 and 4 pi that are that have a tangent of -1. Okay, so here's our unit circle, and where is the tangent -1? The tangent is -1 here and here, right? So that is at 3 pi over 4, and also 7 pi over 4. Now that is between 3 pi over 4 and 7 pi over 4, or are once around the circle, but they are saying actually twice around the circle. So it's 3 pi over 4, and then if you go another 2 pi, 3 pi over 4 plus 2 pi, think of it this, 3 pi over 4 plus 2 pi is going to actually get 11 pi over 4. So that's another one of the answers. You're going to have 4 answers in between here. Okay, we're not doing the 2k pi thing because we actually have a limit, but we're actually, because it's double, this is what I'm doing first, and you'll see where I'm going with this, I hope. So this position is also 11 pi over 4 over here, and this also is 15 pi over 4. So if I add 2 pi to 7 pi. So now I've got these 4 angles. So 2x is going to be, if I do it in order, 3 pi over 4, 7 pi over 4, 11 pi over 4, and 15 pi over 4. All right, but we want to know what 1x is. So what you do is divide each of these by 2, which means double the denominator. So your final answer would be 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8. Okay, so that is your final answer. So when you have a double angle, first find all the answers between 0 and 4 pi, and then, so you find them here, and then you divide them all by 2. Okay, so you might need to come back to this one when you have one of those in the questions. Now, I don't have a calculator with me, so I'm going to do this one, fake calculating it, but you're going to have your calculator. In this case, we do the same thing. We're going to solve. We want to get cosine of that by itself. So first what we do is subtract 1 from both sides. So that means 1/2 cosine of the angle equals 0.2108. So far that's nice. Now to get rid of this half, that means we double. So cosine of an angle is 0.4216. Now notice they're in degrees. What we're really looking for, so if you've forgotten what to do in your calculator, that means we set it into degrees and we are trying to find out this, right? Okay. And when you punch that into your calculator, as long as you're in the right mode, your calculator is going to give you 65.06 degrees. Now, that's great. I'm going to find that on my unit circle. See where that is, because we're trying to find all the places that it's this between 0 and 360. So 65.06 is about here. Okay, so the cosine here is positive 65.06, but it's also the reflection down here. This is also going to have the cosine, the same cosine. So in the first and fourth quadrants. Now we know that's 65.06. So what is this angle here? Well, we're not doing negatives because negative would be out of this interval. To stay in this interval, we've got to go all the way around and see what is the measure of this angle. And in order to find that, you're just going to take 360 and subtract 65.06 to get so you're going to like take out that part. So you're going, when you subtract, you get also 294.94 degrees, okay? And the book has a little bit of a picture for you. So the solutions are both of these. Where is the cosine? 0.4216, and it's in two spots, and they told us where the answers need to be in between these two numbers. Now, if they had said between negative 90 and positive 90, then this would have been negative 65.06 and positive 65.06, but they didn't, so this matters. Okay, the last one on this page is going to be fun to me. We're going to, it's basically a quadratic. So get everybody over to one side because we can't isolate the cosine of u. So if we get them all over to here, just like old basic algebra, you would have this. And then that is going to be something we can factor, okay? That factors out to cosine u and cosine u, and it's going to be plus 1 and minus 1 here, okay, equals 0. So when this is, old algebra here, so that means we need to, either one of these can be equal to 0. So we're going to say 2 cosine u minus 1 equals 0, or cosine u plus 1 equals 0. So I had that and that. Either one of them can be 0. So that means, how do we figure out, so we have like two different things now to solve that look just like example 1. We just have 2. So let's isolate, get that cosine u alone. So now we're saying, where is the cosine u? 1/2, okay? And we're also going to stay in this interval. So we're talking about degrees, okay? And where is the cosine of u? -1. Okay, so we're going to have some possibilities. Okay, so here it is, the cosine is positive 1/2. Well, if I go back to our old unit circle, well, it's positive 1/2. Hopefully you can remember this by now. It's positive 1/2 at 60 degrees. Okay, the cosine is also positive at negative 60 degrees, but we can't use negative 60 degrees because of that. So what we're actually going to do is you go all the way around the circle, so it's 300 degrees is going to be the other spot. It's in quadrant 4. Okay, now cosine u is -1. I think we did that earlier. No, we didn't. We did tangent. So where is the cosine of u? -1. Well, let's go back. Remember, that's going to be right here on the unit circle. So it's 180 degrees, and there's no other option there. That's the only place on this circle where the cosine is -1. So you have now, the answers are, you have 3 different answers. You have 60 degrees, you would give it as a list. Oops, but usually you put your list in order, but I didn't, okay? And these are, I'm going to put the word and, it's not or. These are all the solutions, so be careful with the word and or. Okay, example 6 is a lot like example 5, and a little nicer though, because it's not necessarily a trinomial, it's just we can factor out a common factor, and we can pull out a sine beta, leaving you with a sine beta minus 1 equals 0. Okay, so now again we have either sine of beta equals 0 or sine of beta equals 1, right? Because I add 1 to both sides. And now we're going to have 2 possible answers. Well, a couple possibly, because where is the sine 0? Here's my... So where is the sine 0? Well, this is 1, 0. There it is. This is 0, 1, so it's not that. And this is -1, 0. So here and here, your sine is 0. Okay, so 2 of them. And that is within, and we're going radians because they told us radians here by the intervals. So it's going to be, we're going to use 0, not 2 pi, because notice there's a parenthesis here. We're not including 2 pi. 2 pi doesn't get to be part of the answer. So it's at 0 and pi. Okay, so we'd say 0 pi. Okay, and where does the sine equal to 1? Well, up here, so pi over 2. Now, is there any other place on here where the sine equals 1? And no, there's not. It's just that. So these are your angles. That's your solution. So it's a lot like the one before, slightly easier. The example 7. Now, notice we were able to solve by factoring the last 2. So, of course, they're going to give us one that's not factorable. So if you know where I'm going with that, some of you said you loved the quadratic formula. I would rather avoid it, but in this case, we can't. Okay, so this is a trinomial, and this is unfactorable. There's just nothing we can do. So we're going to put it in the quadratic formula. In this case, your A is 10, your B is -12, and your C is -7. And we're going to put that in quadratic formula. And then we'll talk about how to solve it from there. So your quadratic formula, should I write it to remind you? -b plus or minus b squared minus 4. You guys know this. You don't need me to write it. But I did. There it is. So over here we're going to write it with the, so that'd be a positive 12 plus or minus 12 squared. So that's 144 minus 4 times 10 times -7. Okay, all over 20. Okay, and this ends up, that's 280, right? So 144 plus 280, and that will eventually get us to this, 424 over 20, and that's going to eventually give us a rounded out 1.6296 or -0.4296. So pretend I used my calculator, but actually didn't. I snuck a peek in the book. So what we're saying then is this all is sine x equals that. Not x, but sine of x. So sine of x, basically, so sine of x equals 1.6296, and sine of x equals -0.4296. Okay, so we still haven't solved for x, and we are going to care about the interval here. So you're going to go ahead, it's in degrees, so you've got to look in degrees. And I believe I gave you a huge fat typo. This actually is supposed to be a parenthesis, not a bracket. So apologize for that, fix it. 360 doesn't get to play. So now we're saying what are all the angles who have the sign that is 1.6296. Now, so when you go ahead and put this in your calculator, you might get an error and wondering, well, you would get an error because our sign is never going to be, the ratio for sign is never going to be greater than 1. So this is going to be an error, meaning we're not going to get an answer out of this. Okay, so just ignore that one. Now this one though, if you put in negative, if you go ahead and put that in your calculator as is, then I do believe it's going to give you the right answer, but it might not give it to you. So I'm going to just put it on my calculator here. Might not give it to you the way we need. And okay, so now I'm going to find my sign of that. Okay, so I get negative 25.44. Now the problem is that is not in the interval. So we know where it is now. It's going to be like down here somewhere. To find that within 0 to 360, you're going to just have to take 360, take away or subtract 25.44. So the real answer is going to be 334.56. Okay, these are the same angle, but this one is within the interval that we were supposed to stay within. Those are the boundaries. Okay, example 8. Now, what we'll first do is get everybody to one side. So we'd end up with this, and then we're going to factor. And looks like they both have a tangent of x. So we pull that out, and now we've got this. Okay, so that we pull that aside. So either the tangent of x equals 0, or this. And so I just plug that in, but I'm going to go ahead and not waste your time. That means he must be 1/2. Okay, now the cosine squared of x must be 1/2, so that means cosine of x is plus or minus the square root of 1/2. So what is the square root of 1/2? Well, that is plus or minus, oh my goodness, that's going to be plus or minus 1 over root 2, right? Which is going to actually be plus or minus 1 over root 2. So if we rationalize the denominator, that's actually root 2 over 2. And that is one of our cosines that you're used to. So this is going to be a version of a 45-degree angle, right? So now we've got, where is the cosine? It's going to be a few different places in the tangent. So let's look at our circle. And it's going to be within one circle. What are all the possible answers? So let's first deal with, where is the tangent going to be 0? Well, the tangent is 0, just to remind you, that's 1, 0. It's going to be here because it's the y over the x. It's not up here, but it's over here again. So the tangent is going to be 0. And we're going to say x equals at 0 or pi. So we got those two. Now here we're going to have a few different places where the cosine is root 2 over 2. It's positive, it's right there, it's there, it's there, and there, right? Every one of these has a positive or negative root 2 over 2 cosine. So that means our final answer is going to have six solutions, okay? So our solutions are 0, pi, and then every version of pi over 4. So that's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those are our solutions. Okay? All right, this last one is a little painful in a few ways. There's some things you just wouldn't think to do, I wouldn't have thought to do. So just bear with me, we're going to do it, and we're going to like it. All right, so here we go. the first thing we do here is we square both sides. And that means we don't square each one, we're actually squaring this. It's a binomial, okay? So 1 squared. So to square this, that turns out to be sine squared x plus 2 sine x cosine x plus, and you're gonna hopefully notice a few identities happening. Okay, so what happens here is if we put those two together, we get a 1. So that's the same as 2 sine x cosine x plus 1 equals 1. So now that means 2 sine x cosine x equals 0. And here's another identity. That's the same as the sine 2x equals 0. So I replace that with the identity. Now, this is where maybe squaring it was weird. We wouldn't have known to do that. And then now this part's weird. Now, remember what we said. We're actually, because it's a double angle, that means x is between, x is between, we're looking for solutions that are here, because that's what they told us up here. But because we have a double angle, it's going to look like this. Okay, so that means where is the sign going to be 0? Okay, where is your sign 0? It's right here, right? And it's also here. Those are the two spots where it's 0, but in this case we're looking, it has to be within this, so there's between 0 and 4 pi. So it's going to be 0, so sine of 2x, 2x is going to be 0, pi, then going back around again, also at, 2 pi, and 3 pi, okay? So that's going around the circle twice, which is what we did on the first page. So that means x equals 0, pi over 2, pi, and 3 pi over 2. Now, it would be nice if we were done, but they said when we square both sides, sometimes we'll get values that are not actually solutions. So now we have to take these and check them. So we go back up to the original equation and we try these solutions and see if they work. So like we're going to plug 0 in here. So I'll do it off to the side here. So maybe I'll do it. See if I can find another piece of paper. So I'm going to try these. I'm going to try sine of 0 plus cosine of 0. Does that in fact equal 1? Well, the sine of 0 is 0. The cosine of 0 is 1, and that equals 1. So that worked. Okay, so this actually is a solution. I'm going to underline it. That worked. Now let's try sine of pi over 2 plus cosine of pi over 2. Does that equal 1? Okay, well the sine of pi over 2 is, so we're talking about up here, is 0. And no, it's not, sorry. The sine of pi over 2 is 1. And the cosine of pi over 2 is 0. And that does work. Okay, so these first two are solutions. That was fine. Now we're going to try pi. Sine of pi plus cosine of pi. Does that equal 1? Well, it actually doesn't, because cosine of pi is minus 1. So that does not work. Okay, so that means this is not a solution. And then the last one, sine of 3 pi over 2 plus cosine of 3 pi over 2. Does that equal 1? Well, 3 pi over 2, that's what we're talking about down here. So the sine of 3 pi over 2 is actually negative 1. Cosine is 0, and that does not equal, oops, that equals negative 1. So it does not equal, and that means that one didn't work. So in this final problem, there's only 2 solutions, and it would be that. So unfortunately, you might get 4, but if you don't check, anytime you do any squaring, take your solutions and plug them in and try it. That's why I tried it on this, and I didn't plug it in on anything else. So don't worry that you're gonna have to do that a lot. But Sadly, when I made your notes, I must have flipped a page and not realized that there's actually a couple more examples. So we're going to keep going. You're going to need a fresh sheet of paper. So pause me and get either a blank piece of paper, graph paper would probably be better, or whatever. But we need to do these last examples. The example 10, you're going to go ahead and write. You're going to solve cosine 2x plus sine of x equals 1 in the interval 0 to 2 pi, non-inclusive. Okay, so we're going to do a couple more of these. Sorry. We're going to replace cosine of 2x with the identity 1 minus sine squared x, because we want it to match up with this. Okay. And what's going to happen now is, oops, I wrote it wrong. It's 1 minus 2 sine squared x. And now let's bring that, these ones would go away, so we're left with this. Okay. And let's go ahead and factor out a sine x. And that's going to leave us with negative 2 sine x plus 1 equals 0. And then from there we can solve. So we're looking for the places where sine of x equals 0 or negative 2 sine x plus sine x. Sometimes I forget to do that, put the x on there. Sine x plus 1 equals 0. So what that means is sine x equals 1/2. Okay, so now we're looking for all the places where the sign is 0 or 1/2. Well, sine is 0 at 0 and pi, and its sine is 1/2. Now I'm going to go through this faster. On your unit circle, the sine is 1/2 at pi over 6 and 5 pi over 6. So we've got 4 choices there. Now let's make sure, do they all, they said to go ahead and check them. I'm going to go ahead and tell you they checked, they worked, and they're all between 0 and 2 pi. So all 4 of these, if we do in order, from least to greatest, are our answer set there. That's our solution set. Okay. A lot of these are very similar, so it's just trying to solve for x. Hopefully you're catching on. If not, you know to call me, text me, email, FaceTime, whatever. I'm available all the time while you're doing this. Okay, solve. The exercises for this, though, aren't going to be done until tomorrow, so you're welcome for that. I thought today you would just watch this really long video and fill out notes. That's all I'm asking you to do for Thursday. Okay, so here we are with that. And notice we probably are going to use some identities. We have a secant here. This can be put in secant form. We're going to use the identity secant squared x minus 1 plus secant x minus 1 equals 0. Well, that turns into minus 2. And it looks, I'm not sure if you can hear the noise behind me, but my dog is, I'm in the guest room and the dog is trying to, maybe I'll just show you. My dog is trying to burrow and make a nest, and he can't get comfortable. He's trying so hard. He just keeps spinning around. How you doing, Shadow? Are you frustrated? Okay. Thought you might want a little break. Okay, so then that factors to secant x plus 2 and secant x minus 1 equals 0. So that's going to give us secant x has to equal negative 2, or secant x has to equal 1. So where does that happen? Now it's harder to find secant, so let's think of it this way. The cosine x equals negative 1/2. It's the reciprocal, right? And the cosine is 1. So that didn't change. So It's hard to know secant, so let's just look at it in terms of cosine. All right, well, the cosine is negative 1/2 at 2 pi over 3 and 4 pi over 3, or x equals 0. So we check all the values. They all work. They're all within the interval. So your solutions are 0, 2 pi over 3, 4 pi over 3, and that's it. Okay, now the last example I'm just going to show you. Okay, in this case, they're saying solve for this. Now, we can't do much with this. Sometimes you're just going to have to use a graphing calculator. So the way you would solve and find this answer is we're saying, where does the left side cross the right side? So you would graph two different things. You would graph x squared minus 1.5, and you would also graph cosine of x and see where they cross, where the intersection is. And they found the intersection, so they're saying, okay, so about 1.32. And then over here, they graphed it differently. They put everybody over to one side and found out where they both equal 0. So there's two different ways to do that. I just wanted you to peek at it real quick. I'm not going to worry about it too much. Okay, the second part is they graphed both sides of the equation and found where they crossed. There's they crossed two different places, or they put everybody to one side and found where they crossed the x-axis. In both cases, they come up with about 1.3 and 5.66. So just so you know how to do it on a calculator, I'm not going to have you do that, but I just thought I'd show you.